These two have to be the same. Basically, take that 150 and cut it in half, and you should get, what is that, 75? 75. EF, the measure of arc EF has to be 75 degrees. I know, pretty simple. Not crazy difficult. Until we get to this next problem. This next problem I'm rather a fan of. I like this next problem. It's going to stump you. Maybe not. Maybe you're sitting in your house on this wonderful Friday and you're saying to yourself, well, I feel pretty smart right now. That last example was super easy. Good luck on this one then. Circle. C. Give yourself a diameter. Give yourself a perpendicular chord. Let's call this E. Let's call this B. This is going to be F. D is going to be right there, that intersection point, and we'll put A over here. Alright. I'm going to tell you a couple things, and then I'm going to ask you to find something. I'm going to tell you that AB is 18 inches long. I'm going to tell you that chord EF is 8 inches long. And everybody, I'd like you to find CD. I'll tell you, this is a tough question. Once again, I wish I had students that I could look around in the classroom and say, hey, are there anybody know how to solve this? And I could stand up from my desk and walk around and kind of see who's really thinking this morning. But we don't have that. Everybody's stuck at home. Everybody's still in their pajamas. CD. We need to find this distance from here to here. So I'm going to call this X. Alright, what do we got? AB. AB is 18 inches. So from here to here, the diameter is 18. So you could say that the radius is 9. So that's 9. And the distance from C to B, which is also a radius, is 9. I'm not going to put 9 from here to here because it's going to get a little confusing if I start writing on this. We already have a lot going on here. I just know the distance from here to here is 9. That's 9. Add it together, you get the 18 diameter. Alright, so that's taken care of. EF is 8. E to F is 8, which we have a theorem. If we have a right angle right here, that means that these two pieces are exactly the same. If this total distance is 8, that means this has got to be 4, and that's got to be 4. I get kids that say this all the time. They put the 4s there. I mean, oh, this is easy problem. 18 inches, that's 9. And then they try to figure out what this distance is, and they get stuck. Here's what they do. I do have kids that say CD is 9. No, that's not a radius. Some kids do this. They say, well, 9 minus 4, 5? The distance is 5? No, that doesn't make sense either. And then the confusion sets in. How do you find this distance? Man, I wish I was in my classroom right now and I could look around and see you guys thinking. Because I can't see you thinking behind this computer. I can't see you thinking at all. Oh gosh. Some people kind of make guesses. 7, 5, 2. I know that distance is 9, but what the heck is X? Here's what I want you to do, folks. I'd like you to make a radius. Here, we already have a radius right there. That distance is 9. Make another radius right below it. It's a radius, right? That's 9. Make another radius. Anywhere in a circle. If it's a radius, all the radii have to be the same. That's 9. Make another one down here. That's 9. I want to make one more very important radius. I'd like you to make a radius from C to E. Isn't that also 9? Isn't that also a radius of the circle? And what you just created is a right triangle. If that's a right angle right there, you got yourself a right angle right there. And I want you to focus on this right triangle. Some of you might need to redraw it. Draw it outside of the circle. Here, let's redraw it. I know it's a right angle. We need to solve for X, the distance from C to D. And I know that's 4, and I know that the radius is 9, also known as the hypotenuse. How do we solve for X? Hopefully you remember this. Hopefully you haven't gone brain dead just yet. Right triangle, we need to find a side. Let's use the good old-fashioned Pythagorean theorem. A squared plus b squared equals c squared. Alright, here we go. Let's go ahead and solve it. Meet you at the problem. Or meet you at the answer. Okay, x squared plus 16 equals 81. Subtract 16 on both sides. If I have $81 and I lost $16, I've got 65. 65? Trying to do some mental math. Yeah, 65. Yep. Perfect. X squared equals 65. Square root both sides. X equals the square root of 65. Now let's see if we can break down the square root of 65. I don't want decimals. Folks, if you have a calculator out, put it away. In fact, throw it at your wall. Just kidding. Don't throw it at your wall. Your parents are going to hate that. Simplify the square root. You need to know how to simplify square roots. 5 times, what is it, 13? 5 times 13? Yeah, 65. Prime number. 13 is also a prime number. You can't simplify this, can you? Okay, I guess that's the answer. X equals the square root of 65. That distance is the square root of 65. Keep this in mind, and you're going to have some questions like this in your homework. Draw a radius and make yourself a right triangle. You'll get the answer every single time. Last theorem. Theorem number 3. Last theorem. Very easy. I'm not going to draw an if-then, folks. Make a circle. Give it a center. Call it center L. I need 2 congruent chords. B. Let's make another one like B. Okay. F, G, H, J. You know what I said? I'm not going to do an if-then. I might do an if-then. I might do an if-then. Sorry. I would like you to, from this chord, I'd like you to make a perpendicular distance to the center. Let's call this X. Make a right angle right there. Same thing with this other chord. I'm going to turn this paper sideways just a little bit. I'd like you to make a perpendicular distance from the center to that chord. And let's call this Y. Alright, here's the last theorem. It's a good one. It's an easy one, folks. Yeah, I gotta do an if then. Sorry. My bad. If these chords are congruent, if FG is congruent to JH, let's slow it down a little bit. Make sure we're all looking at the same thing. If these two chords are exactly the same, then what this theorem says is these two perpendicular distances to the center have to be the same. Then XL has to be congruent to YL. Nothing fancy. If these two chords are the same, perpendicular distance to the center, these two pieces have to be the same. That's your third and final theorem. I got one more example for you, and then we done. Example 4. Then we done. That's not example 4. Example 4. Draw a circle. Give her a center. Let's give 2 congruent chords. Let's call this EF. Let's call this HG. And let's see, do they even look? Yeah, they look congruent. I'm happy with how they turned out. Oh, that's a chord. I'll highlight that, highlight that. Alright, those 2 chords are the same. I'd like you to find the distance from that chord to the center. It has to be perpendicular. Also, going back on the last theorem, not only are these, here, let me draw this really quick. Making sure it looks like a right angle. Not only in the last theorem are these 2 correct, but it's actually going to break this chord into 2 pieces, equal pieces. So that is the midpoint right here. So you can say that these 2 are exactly the same, and you can say that these 2 are exactly the same. Goes back in the last theorem, but really all you need to know is if these chords, these yellow chords are the same, these 2 pieces are the same. Alright, what do we got? What do we got? I'm going to tell you that those are the same. I'm going to tell you the EF is congruent to GH. And I'd like you to find, here, let's call this P, call this R, call that Q. Let's see. I'd like you to find PQ. And I got to give you some expressions, so not really done here. PQ is, let's see, 19x plus 10. And PR, I got to give you an expression there. How about 3x squared minus 4? All of you can start this problem. Not too crazy. These have to be equal from the last theorem, so go ahead and set them equal. 19x plus 10 is equal to 3x squared minus 4. Alright, folks. It's been a long time since we worked with quadratics. It's been a long time since we've seen an x squared. When I say quadratic, that's an x squared, everybody. It's what we call a quadratic. Talked about this in Algebra 1. To solve a quadratic, get everything set equal to 0, and then we're going to factor. So, what I'm going to do is I'm going to subtract 19x on both sides. That's going to cancel these. And I'm going to subtract 10 on both sides. And that's going to cancel these. So 0 equals, put it in standard form, meaning the x squareds come first, x's go in the middle, and then we're going to finish with the numbers minus 14. Oh, minus 19x. Forgot the 19x. Alright, let's factor. Let's factor. Honestly, I'm going to put the 0 on the other side, because I'm OCD like that. It's the exact same. They're the exact same thing, folks. Factor. I'm going to multiply first term, last term. If you multiply those together, you get a negative 42x squared. And let's find some factors that not only multiply to get negative 42x squared, but also add to get the middle term. All right. So let's start just jotting down some factors. How about 42 and 1? I know 2 goes in. 2 and 21? One of them has to be negative. That works. It multiplies to get the negative 42, adds to get, oh boy, that does not add to get negative 19, adds to get a positive 19. That ain't going to work. How about we take that negative and put it on the 21? How about 2x and a negative 21x? I think that's the answer. I think that's the answer. Yep, got it. 3x squared. Let's rewrite that negative 19x plus 2x minus 21x minus 14 equals 0. And what we're going to do is factor by grouping. So I'm going to group these first two terms. I'm going to take out a greatest common factor. Greatest common factor of these two terms. There's no number that goes into 3 and 2, but you can take an x out. So you're left with 3x plus 2. And let's do the same thing with these second two terms. Take out a greatest common factor. You can't take an x out because there's no x occurring in the negative 14. But there is a number that goes into negative 21 and negative 14. How about a negative 7? And you should be left with 3x plus 2. Don't forget the equals, don't forget the 0. Alright, 3x plus 2, x minus 7, there's your repeat. X minus 7 is the two greatest common factors that were pulled out, set it equal to 0. And now we do the 0 product property. X minus 7 equals 0. How about 3x plus 2 equals 0? Add 7 on both sides. X equals 7. That's one answer. Subtract 2 on both sides. And divide by 3. X equals negative 2/3 is your answer. Okay. Folks, we are not done because we need to find PQ. Let's find PQ. I'm looking at the negative answer. It's not going to make sense. It just doesn't. You can go ahead and plug it in. It's not going to work for this expression. It's going to give you a negative value. So that's gone. X equals 7 is the only answer, so go ahead and plug it into PQ, which is this expression right here. 19 times 7 plus 10. 19 times 7 is, let's see, 70, 133? Plus 10, 133 plus 10 is 143. Everybody, that's your PQ. Your homework is found on page 719. I'd like you to do problems 8 to 14, 16, 17, and 44 to 46. Folks, make sure I get this by midnight tonight, and you'll be good to go. Have a great weekend, folks. I'll see you on Monday. Adios.